Today we are going to solve systems of equations using graphing here first, and then in video B here we'll do substitution, but we're just going to focus on graphing right now. So there's a couple of different ways to graph the systems of equations here. We could go ahead and put it in y equals mx plus b if we wanted to, or we could just go ahead and graph using our x and y intercepts. Since most of you will probably choose to use your x and your y intercepts, that's the way I'm going to do it for now. That might be one example I do later on where I'll put it in y equals mx plus b form and then try to graph it. It's completely up to you. So this first one, 2x plus y equals 5 here, I'm going to use the cover up method here and go ahead and cover up the x's. If whatever I cover up is my 0, so for instance here, if I go ahead and I cover up um, x there, then I can solve for y, and y just ends up being 5. So my nice ordered pair here is this 0, 5. And then likewise here, I can do very similar here with the first equation again. To find the x-intercept, I can cover up the y value this time. So the y here is going to be 0. And I can solve for x. So I can divide by 2. So x ends up being 5 halves. Or if you wrote that as a decimal, that would be 2.5. So now I'm just going to simply graph those. I've got 0, 5, and I've got 2.5, 0, and then connect my points. You probably want to use a ruler on this just because you're trying to figure out, when we're graphing these, we're trying to figure out where the two lines there are going to intersect. What point are they going to intersect at? So now I'm going to go ahead and look at my other one here. I've got x minus y equals 1. I'm going to cover up the x. So remember that's going to give me 0 something now. So I end up getting negative y there equals 1. I'm still solving for y, so I got to divide by negative 1. So y ends up being negative 1. So there's one of them. Now I'm going to try to find the other one now. So I'm going to rewrite it, x minus y equals 1. This time I'm going to cover up the y. So the minus y there. So I know my ordered pair there is going to be something 0, so I end up getting x equals 1. So now I can plot those two ordered pairs there. I've got 0, negative 1, 0, negative 1, and I've got 1, 0, and I'm going to go ahead and connect those. So we can see that our intersection point there is at 2, 1. So again, we could substitute it back in here to see if it's true here. 2 times 2, there's 4, plus 1 gives me 5. I can put 2, 1 in here. 2 minus 1 gives me 1. So it does indeed work for both equations. Therefore, it is our solution of where the two lines intersect. So when we're graphing our systems here, and our system is just a set of two linear equations here in this case. Our system has 2 of them. Could be more than 2. But in this case, we're just going to do 2 of them. We're trying to figure out where those two lines intersect at, and they intersected at the point 2, 1. So let's try another one of these examples. This one here, you've got 5x plus 4y equals 7, and you've got negative x minus 4y equals negative 3. So in this case here, harder one here, but we can still do it. So 5x plus 4y here equals 7. I'm going to do exactly what I did before. I'm going to cover up the x here, so my x value is going to be 0. I get 4y equals 7. I'm going to divide by 4, and I get y equals 7/4, which if I go ahead and write as a decimal, it's going to be 1.75. And then I'm going to try another one here. Your other one here to go the other way here now. I got 5x plus 4y equals 7. This time I'm going to cover up the y. So that is going to, the y is going to be my 0. I'm going to divide by 5 here. And I end up getting x equals 7/5. And that ends up, if you divide that out, that ends up being 1.4. So let's go ahead and let's graph those out. We've got 0, 1.75, and we've got 1.4, 0. So I'm going to connect those. And then I've got my other equation here. I've got negative x minus 4y equals negative 3. I'm going to go ahead and cover up the x value. So now my x is going to be 0. And I can divide by negative 4. So I get y equals 3/4 or 0.75. So plotting that out, 0 and then 0.75. And then we've got another one here. We've got negative x minus 4y equals negative 3. This time I'm going to cover up the y's. So my y value here is 0. Divide by negative 1, and x is 3. So we've got 3, 0, 1, 2, 3. And we can connect those. So this time it's looking kind of difficult as to figure out what in the world point that is. It might end up being, let's see, we got 0.75 and we got 1.75. So looking at this, having a hard time kind of figuring out what that ordered pair there would be. So we might want to go ahead and put that in y equals mx plus b form. Or the other thing might be that we kind of guessed. So I'm thinking maybe 1 and then a half. So my guess is it's 1 and then a half, and I could put it in here. 1 and then a half. So 5 plus 2 gives me 7. And if I put 1 and then a half into this other equation here at the very beginning, I get a negative 1 minus 2 does give me negative 3. So the ordered pair 1 and then 1/2 there does work. The other thing would be to put it in y equals mx plus b form, but that can kind of get kind of messy to graph that out too, just because you've got a 5 in front of the x there, but we could do that. If I were to do that for this one, we've got 5x plus 4y equals 7. I could subtract 5x. I get 4y equals negative 5x plus 7. Divide by 4. And y equals negative 5/4 x plus 1.75. So again, just because you end up with a decimal over here, it just makes it more difficult to graph out. But again, sometimes if you use a ruler when you're graphing those lines out, it makes it a lot easier to graph out because you'll see it more exact that way. So letter C here, you got x minus y equals 5 and x plus 2y equals negative 4. Let's keep going on here with, and I'll show you on this one how to kind of do both of them if you want to do the x and y intercepts, or if you want to go ahead and put it in y equals mx plus b form. So covering up the x here, I get negative y equals 5 divided by negative 1, and I get y equals negative 5. And so I'm going to do the other one while I'm at it. This time I'm going to cover up the y. So I get x equals 5. So I've got 5, 0. And I've got 0, negative 5, 1, 2, 3, 4, 5. And then I can simply connect those points. My other one here, x plus 2y equals negative 4. Cover up the x here. Divide by 2. Y is negative 2, so I got 0, negative 2. I'm going to rewrite it again. This time I'm going to cover up the y here. So I get x equals negative 4. So I can plot those. I've got negative 4, 0, and 0, negative 2. And I can connect those. And it's looking like it's right there. 2, negative 3. Again, I'm going to check in the original problem up here. I've got 2 minus a negative 3 becomes a 2 plus 3, which does give me 5. If I put 2 and negative 3 back in over here, I get 2 plus a negative 6 does give me a negative 4. The other way again would be to put this in y equals mx plus b form. So if I subtracted x here, I get negative y. equals negative x plus 5. Divide by everything by negative 1, and we get x minus 5. So then I could plot my y-intercept down here on my graph here at negative 5, and then rise 1, run 1, rise 1, run 1, rise 1, run 1, and see how your dots can get more exact that way. Same thing with the second line here. It's x plus 2y equals negative 4. I could subtract x. I get 2y equals negative x minus 4. Divide by 2, and y equals negative 1/2 x minus 2. And again, I could start down here at negative 2. I could rise negative 1 and run 2. Rise negative 1, run 2, and so on and so forth. It just makes it more exact if you put it in y equals mx plus b form, but it's up to you. Okay, we've got one last example here for the graphing part for this video. This one here, they're already in y equals mx plus b form, so y equals mx plus b. So looking at that first equation up there, this is the 4 there is my y-intercept, and this here is my slope, the negative 2. So I can graph my y-intercept, and then from that I can go down 2 and over 1, down 2, over 1, down 2, over 1. Connect my points. And then my second graph there, again, this is my 1 there is my y-intercept, and my slope there is just 1 over 1. So y-intercept up there at 1. I can rise 1, run 1. So rise 1, run 1, and then we can rise 1, run 1, and you can clearly see that we're intersecting a point there. The ordered pair there is 1, 2. So that is my solution there. That's where the two lines there intersect at. So that concludes this lesson. So there you are.